All right, guys. We are talking about confidence intervals. So this is inside your notes packet. So if you weren't there already, go ahead and find your way here. Okay, so the reason we make a confidence interval is we're estimating something that is unknown. So that's the biggest thing to think about. It's an estimate of something that is unknown. You still have means or proportions problems, so you have to figure that out, okay? So like a means problem, I could ask each of you to estimate Oprah's net worth for me, something like that, okay? You're just making a guess about an average, okay? If it's a proportion like we just did, you could have made an estimate from your sample of how many red M&Ms, like what's the proportion of red M&Ms in a bag. Okay, there is a truth out there. There's a true mean or a true proportion. You just don't know it yet. So you're going to make a guess based on your little sample that you took. You've seen confidence intervals. Have you guys ever seen like the results from a poll are, 29% in favor with a margin of error of 4%, or like plus or minus 4%? So if you added or subtracted that 4%, it'd give you a range. That's a confidence interval. Okay, so a confidence interval is like, I think the truth is somewhere in between these two values. Okay, and we're going to actually calculate that for the proportion of red M&Ms in a bag. All right. So that kind of goes into part 2 here. What is a confidence interval? So realize it's always an interval. Okay. We're making an estimate, and again, we're trying to estimate this unknown parameter based on a sample. So like you just had a sample of red M&Ms. That's what you use when you create a confidence interval. Okay. Then there's a process to go through when we make a confidence interval. Again, you've got your sample, and then you make an estimate based off of that sample. First thing you're going to do, you will always, always, always check your conditions. So the random, that's going to either be stated or assumed. That hasn't changed from what we've done in the past. And then normality, a couple different ways depending on if you're looking at means or proportions. So if it's a means problem, it's either going to be stated. What is central limit theorem? Like, why would I have that? What am I talking about there?
Large sample size.
Yeah, so that's that whole n greater than or equal to 30. Okay, which is why we have 35 M&Ms in our sample. What does this mean? What's the NPP? Yes, normal probability plot is approximately linear. Okay, that is still in play as a way to check for normality. So if I give you a sample set of data values, and you have to put them in your calculator and go through the 1-bar stat and find X bar and find S, you could check the normal probability plot, right? Do you remember how to do that?
Yep.
Yes, someone tell me how.
Y equals the stat plot. And on maybe the last one.
The last one, yes. Yeah, you pick that last one. You just look, is it roughly linear? That's what we're hoping for, okay? If it's a proportions problem, now it's just n times p hat has to be greater than or equal to 10, n times 1 minus p hat greater than or equal to 10, okay? So really none of this part is drastically new. The only thing that's changed, we're talking about p hat instead of p, because we don't know the truth from the population. We just have our sample to work with, and we're creating everything from that sample, okay? So we only have our statistics that we can work with. All right. Then we find the point estimate. This is the best guess that we are starting with, okay? So for you guys, your best guess is what you found in your sample. So you each have your own best guess of what the true proportion for red M&Ms is, okay? So different sample is going to yield a different best guess. Does that make sense? Use the one you have, okay? Means problem, it's X bar. Proportions problem, it's P hat. Okay, that's probably not surprising. And then the point estimate is always in the middle when we're doing a confidence interval. So you have this range of values here. Right in the middle, that is your point estimate. Estimate. So let's say it's 10%. And then our margin of error, our plus or minus, let's say that was plus or minus 2%. My range then is 8% to 12%. So that whole range, the 8 to 12 is the confidence interval. The point estimate is just that value right in the middle. Does that make sense? And when we do some of these, you're going to be like, all right, but it's always in the middle. So the margin of error, I just made one up here, this plus or minus 2%. That's what you're adding or subtracting from your point estimate to get the actual interval. Okay, and then there's some formulas we do with this, whether it's means or proportion. If we know sigma, we can use it. If we don't know sigma, we have to use S, and that's when we're getting into those t distributions, which again, I didn't count any of those against you on your tests. Okay. I'm going to do something. If you got like 7 or 8 of them right, I'll give you something back on your test. If you got like 5 or 6 of them right. If you only got like 1 of them right, I'm going to give you ones back on your test. Okay. So you just have to recognize which formula we're going to use, and the confidence level is going to help determine what our critical value is. Okay. So we could say I want a 95% confidence interval, or a 90%, or a 99%. That can change throughout the problems. Okay, and we'll talk about what those mean a little more here in a second. Questions so far? I know I'm kind of giving you a whole lot of information without doing any practice problems yet, so, okay. Okay. All right, critical values here. Couple different ways to think about what a critical value is. So do you see how it's a z with like a little asterisk next to it? That tells you it's a critical z value. Okay, sometimes it's written as z crit, like you might see, and then a little subscript of crit. That just means critical z, or z with the little star next to it. Okay, those mean the same thing. So the first one here, if I'm looking at a critical z value for 95%, think about what that means. I'm talking about 95% of the values being in there. I'm looking for the z-score then that is associated with either this point or this point. One of those is going to be a negative z-score, one's going to be positive. But remember, we're doing plus or minus, so it really doesn't matter which one you find, they're going to be equivalent. You can use the empirical rule, and you should know what it is. Anybody have a guess? What's the z-score right here? 95% was one of our close. 2, yeah. Remember, like, if we had 68% of the data, that was 1 standard deviation in each way. 95% was 2 of them in each direction. You can also get this from your calculator. So let's do it that way because we aren't always going to know from the empirical rule. So go ahead and get out your calculator. We're going to do inverse norm because we are trying to get a z-score. Let me open up mine real quick. All right, guys, how do I get to my inverse norm? Second bars. Okay. All right, inverse norm. Okay, and let's look at what it asked me. All right, the area. So let's think about this. We're going to do it for the 95%. Remember, 95% was in the middle. How much did that leave in each tail? 2.5%. That's what you're actually going to put for the area. And I'm not going to do 2.5. What am I going to do? 0.025. Good. And then you can leave this with the 0 and the 1. We'll just do a standard normal curve. That's completely fine. And then paste. And so if we can get a negative result, hold on, one thing at a time. We're talking about the middle 95%, right? So that leaves me 5% to split between the two tails. And that's 2.5% in each, right? So 2.5%, and that's why we use like, okay, I'm looking at 0.025. Yes. Okay, and now Beckett, you said, why is it negative? Yeah. So if I did the 0.025, that's left of my mean, right? So it's going to have a negative z-score. You could have also used 0.975, and you would have gotten positive 1.9599. Does that make sense to you guys, why you would get negative versus positive? I think it's easier to key this in because you're just taking whatever's left of the interval and dividing it by 2. Okay, but if you like the positive one better, that's fine. All right, so let's look at a couple more. Is this close to 2 standard deviations? Yes, okay, so hopefully that gives you an idea that you're on the right track.
So it could be 2 or negative.
I would take 2 or 1.96. And you're going to list the positive one, even though what we found was negative, because it's always plus or minus that critical z value times your something else that you're plugging into your formula there, okay? So it doesn't matter. We usually call it the positive one when we begin. So I want you guys to try to find the critical z value for a 99% confidence interval. Okay? So think about what that's going to be. I would use your calculator. 99% confidence. Sharing calculator. Yeah. So it's the z-score associated with that percentile. So we're talking the middle 99%. It's associated with 99.5. We're going to use that to calculate. Okay, it's like one of the pieces that will actually we need to be able to find those different.
But I mean, I know you just do the same thing. When you put the
One of those where you like take this building block and then once you find it all together, you're like, so just.
I'm just thinking.
Yeah, we'll get there. We'll get there. I know. Don't worry about it. All right, guys. Walking around, it looked like you were doing very well. This one I'd take 2.575. If you rounded it to 2.58, that's great. Probably wouldn't go all the way to 2.6. You might be okay, but I would.
I actually got 0.276.
0.276.
0.2576. No, 2.576.
Okay. So are you okay with 2.58 then?
Sure.
Okay. All right. So do it for the 90% and the 85%. A lot of you already did, but just go ahead and.
You know, why don't we just round all these to 0?
To 0. No, that's not really going to help us.
Does it matter where we round to?
Not really. I would go at least 2 decimal placements. It's more about process and interpreting your answer than like do you do this decimal place, you know, when you get to the end. So
That's really weird.
it's very different from all your other methods. Yeah, I know. It's a little hard to swallow.
Last year, like, I got points taken off because I was at 4 decimal places instead of 3.
Yes. Yes, that one. Okay. Like, close, and then you wrote the right words afterwards. Perfect. All right, guys. So Z-crit for 90% was roughly 1.645. Way around there somewhere. And for 85%, something like 1.44. Okay. So that's just giving you the Z-score associated with that percentage location in your normal curve. Okay. And this is just a piece of what we use to calculate our confidence interval. All right. We're finally going to talk about T's.
If there's a negative number, would you get it wrong?
Now, if you listed the negative, it's common practice is to do the positive, but when you're going to do plus or minus at the end, you're going to get the same thing whether you have a positive or a negative. Okay? All right. We're going to deal with the T. And this should say when sigma is unknown. Okay? Not known. It's unknown. All right, guys. So look at this first one. I'm asking you 95%, and then I have 10 df. The df is degrees of freedom. Okay? We have 10 degrees of freedom. Degrees of freedom is always 1 less than your sample size. So it's always n minus 1. Jot that down over here. So df always equals n minus 1. Okay, I'm giving you the degrees of freedom this time. So for the first one there, T-crit 95%, degrees of freedom 10. Let's look at that. So we're going to go back to that second VARS menu. Yeah, I'm not going to pick inverse norm this time. I'm going to pick inverse T because that's the type of distribution we're talking about. So, and look, it asks you kind of different questions, okay? So area, if I'm talking 95%, remember that's the middle 95%. 0.025, okay, we're catching on. And now degrees of freedom were given to you. It was what, 10? And we're going to write down 2.228, okay? Anybody questions on getting to that inverse T menu or any piece of that? So this one was 2.228. Do you notice how that's a little bigger than our Z-crit for 95%? Okay? If you're talking about a t-distribution, it looks a lot like the normal distribution, but the tails are fatter, so it makes sense that there'd be a little more under the curve out at the ends, okay? So let's do the same thing, but now your degrees of freedom are 20. So go back in, 95% confidence, degrees of freedom 20. No, it like thinks more on these, doesn't it? Yeah, it's funny. Are you getting 2 point? Okay, I'll write 2.086. What are you noticing? It's getting smaller. Is it getting closer to the Z-crit for that confidence level? Okay. Oh, try it with 30 degrees of freedom.
Whoa.
I think it's going to go down. I think you're right. What do you mean? Yeah. If you're, you don't have, when we get to the actual problem, I'll show you what you need to write down for your keystrokes, okay? Did you get 2.042?
Yes.
Yes? So, as sample size increases, what do you think happens to your t-distribution? As sample size increases, what happens to your t-distribution?
More and more.
Yeah, it's closer and closer to the normal. Okay? You see what you're doing? Okay, good. Oh my gosh, everywhere. All right, so calculate those last few there. The 85% was 17 degrees of freedom. I'm going to write them up here. You can check once you get there. 99%. 80%. You can see the confidence level stayed the same, but this changed, and you see how that is closer to this than either of these.
The degree of freedom was at like 60 degrees. What would make it exact 100?
No, it's just the bigger it gets, the closer and closer. It like approaches it.
It can never become exact.
Yeah, there's no limit. Yeah. I don't know. I feel like you get large enough. You're talking decimal values.
Yeah.
They're going to be different stuff. Okay. All right, guys. Any questions on the inverse norm, inverse t? I see a couple people still calculating. Give me another minute here.
Terrible day.
You're right.
It's not terrible. You got mine.
Yeah.
Right? You got 35.
That's the highlight of my day.
Highlight of the day.
When I go home, I see how school is like good. So that's where
Productive day in that day.
I
All right, guys. So
Another one.
let's talk about what this actually means if we have a certain confidence level. The wording when you write your conclusions is very important. It's also very sort of fill in the blank, follow the formula kind of writing. Okay? So when you're 95% confident, what we're talking about is if we did this over and over and over and over with the same sample size and the same confidence level, the same critical value, you're going to capture the true parameter, meaning the truth is in about 95% of those confidence intervals. So if you did 100 samples of the M&Ms and you were 95% confident in your interval that you created, that means like 95 of those 100 samples would capture, or intervals would capture the truth. Okay, so like you're creating this little window, 95% of the time that window will contain the truth. Okay. All right. We'll do it with the M&Ms too, and I think that will help you.
We're gonna get up an example.
No, we're not. I don't have that many M&Ms. So what you're doing is looking for the truth, okay? We want to know. You're searching for the truth, guys. That's what we're doing instead. So, and I'm going to write them when we get to some examples, but how you interpret it, this is what you need to say. We are 95% confident. Not that there's a 95% chance, anything like that. We are 95% confident that the true proportion of, talking about our red M&Ms here, is, and then you give your interval, and then whatever unit we're talking about. That's what you create with that plus or minus the standard error, or margin of error. I know, it looks weird the way it's written there. But again, don't say that there's a 95% chance or 95% probability. You must say we are 95% confident. Like that is absolutely the beginning of every one of these. You must write this on your paper, okay?
Okay, so right, there's a 95% probability that we've captured the true parameter. Got it.
No, Beckett. We'll give you eyes on all of your free response if you do that, okay? All right, so then before we get to an example, we're going to look at how we can make it narrower. All right, if you increase your sample size, which does that make sense? The bigger your sample is, we're going to have more confidence in our answer. Like if you sampled half of that big bag of M&Ms instead of just 35 M&Ms, would you be more confident that your interval is going to capture the truth?
Yes.
Okay, all right. And we'll talk about that more too. Let's come back to 8 when we get to the example that deals with that. Okay, turn the page. These are just the formulas you have to know, the formulas you must write down on your free response questions, okay? So if your sigma is known, you've got your point estimate, that's your x bar, plus or minus, and then it's your critical z value times your standard error. If you don't know sigma, the same thing, but we're using a critical t and s instead of sigma. Proportion, you only get one formula for proportion involving your p hat. And again, we'll look at this again in a little bit, the whole solving for the sample size. Okay, those are just formulas, things you must write. Let's try one, guys. All right, so we have a simple random sample of 1,100 males, aged 12 to 17. They were asked whether they played massive multiplayer online role-playing games. Apparently, and the acronym MMORPGs. 775 said that they did. We're going to construct a 95% confidence interval to estimate the proportion of all U.S. males aged 12 to 17. Yeah, that play more. I can't say that.
Let's just say roll.
MMORPGs. Okay, first, means or proportion problem.
Proportions.
Yeah, proportion, right? Proportion, okay. Good job, guys. All right, so we're going to start by writing out some things that we know. We don't know P, right? We don't know the entire population. All we have is our sample, correct? Okay, so that means we know P hat. What is P hat? How do I find it?
1,100.
That is N. We need that in our P hat. How do I actually find P hat?
775.
Yes, 775 over 1,100. And that is 0.2. .7045. Okay? So we have our p hat, we have our sample size, we need to check some conditions. Okay. Is it a random sample? Yes, how do I know?
Stated.
Stated, random, stated, check. Okay. Checking for normality. What do I do with a proportion problem? N times p hat and n times 1 minus p hat. So n times p hat, go ahead and do that for me. What you get?
We're basically drawing conclusions are going to be greater than. Basically, we're drawing conclusions that are only greater than 10, right?
Correct, but even if it's obvious, if you don't write it, you will not get full credit on the proof. Okay? So it's what, like 775? Clearly greater than or equal to 10. N times 1 minus p hat is about, what, 325? Also greater than or equal to 10. Okay. Conditions met. We can then continue with our confidence interval procedure. Okay? That's the problem.
So you needed both of them?
Yes. Yes. Yep, you have to have both of them. Okay. Let's think about our critical Z value here. So our critical Z for 95%. I think you already found it. You could find it again with your calculator though. What is it? Yeah, 1.96, that sounds great. Okay. Then what you have to show me is that you understand which formula you're using. So it's a proportions problem, so I'm going to be doing, and you could even label it. Let's say 95% confidence interval. You can abbreviate. I'm going to be doing p hat plus or minus my z crit times standard error, which for proportion is p hat times 1 minus p hat over n. Okay. For right now, guys, I want you to show me what you are plugging into each of these steps. As we get later in the year, I'm actually not going to want you to show me the work. It's very interesting on the rubrics from the AP exam. They say no work shown but correct answer, and correct labeling, formula, all of this, you'll get credit. If you have the right answer but wrong work, they'll take points away from you. But if you have no work and the right answer, you'll get full credit.
You can't get penalized from work if you have no work.
Yeah. Nice one.
So for us, we're going to start out, just so you understand, I want to make sure you understand where everything's coming from. We're just going to fill in what these things are. So our p hat is 0.7045 plus or minus our 1.96, and then square root of 0.7045 times 1 minus 0.7045 all over 1100. So, because of this plus or minus, you should be getting 2 answers. I want you to try keying this into your calculator, okay? This is where some of the mistakes happen. Yeah. Yes, go ahead. All right, guys, so key that in and let's see how you're doing.
Saying on the answer that 2 mean that like p hat.
Well, no, the true P. Like
Okay.
mu versus you calculated it with X bar. P versus you calculated it with P hat.
So for this one,
The true proportion
is that just?
is within this interval that you're giving. I'll show you if I would be correct.
And do we like draw a sketch?
Not really with these, yeah, it's weird. It's like the one thing you don't make a picture for. I've written the correct interval up here. If you are not getting this, raise your hand and I will come help you with your calculator. So yes, this means you should try to key it into your calculator so you know whether or not you can do it.
It's what like one, it's like off, like that's 0.781.
What was your other one?
Yeah.
Anybody calculators from this? Because it's the time. Point 731 is fine. I think that's actually, I'll change mine up there. I think it's most of you guys get 0.731 instead of 0.732. Yeah. It's always the smaller one. Yep. Sure. It's like interval rotation. Oh, and you're doing your answer. Hold on. All right, guys, so let's write the answer the way. So what you would say is we are 95% confident that the true proportion, guys, write this down. Proportion, I ran out of room, of 12 to 17-year-old U.S. males that play MMORPGs is between 67 0.8%, and 73.1%. Is there any part of that you guys can't read? I know I sort of smooshed it in the corner. So every time we are, whatever confidence level you're talking about, confident that the true portion, mean, whatever we're dealing with, of context of your problem is between whatever percentage and whatever percentage you found. Okay? Don't try to be creative and no, just write what I'm telling you. Okay, please. Questions anywhere on this? Yes, so when you actually do, like when you do the confidence interval, so you've got your formula, write out what the interval is and then do it in context in your conclusion. Okay? All right. Questions? Okay, so the next one, part B, is where we're going to actually solve for the sample size. So let's pause and we'll do that after lunch, okay? So, because if you do like enzymes you had, it's not quite there. So let's just continue.
I'm so done.
If you're stuck at all, let me know, because everybody is going to tell me what your interval is. You guys won't all have the same interval, okay?
Yeah, it's a pretty weird interval.
You got a weird interval, okay?
Your interval for full two negatives.
Yeah. It's right. Oh, you're
I got negative 8.9% to 30.2%. Is that fine? Yeah, mine and Leo's will be the same thing.
Yeah, okay. Since this is that's 3 hours, right?
Is what that means. That's great. There's a Z thing here. It's a multiplier by this.
And then add.
That was just. So I'm gonna calculate these first.
Is everybody using like the 1.645 for your critical Z? Yours are weird, okay. Another minute here, we'll let everybody finish, and then you don't have to put this on your paper, I'm just gonna explain what once you're done. Everyone has a different answer, so. Yes.
I doubt that seems impractical since there's an extremely strong chance that one of them got Satan or red M&Ms.
Okay.
Oh, I have everything.
All right, guys, I'm gonna have you just, we're just gonna go around the room and you're gonna tell me what your interval was. We'll start over here with Matt. Yes, give me the percentage.
21.1 to 47.2.
Okay, so I'm gonna estimate where he is. Okay, somewhere in there. Mardia, what'd you have? You were like 0.
0 to 31.
Okay. And I'm sure I'm not gonna be perfect with all of these. Caitlin, let's keep, oh, are we not there yet? Oh,
I didn't
okay.
have a calculator, so I was calculating.
18.1% to 39.
I'll explain what this line is eventually.
Oh, I got 6.6%, 27.6.
What's S?
Standard deviation of your sample. Okay.
I got 0.089% to 0.31%.
Wait, what? You mean 8% to 31%, or?
Oh, yeah, 48%,
Okay.
8.9% to 31%.
Perfect. All right.
2.56% to 20.
Somewhere in here. Okay. You're still working on yours. Okay. Avery?
That's 6.6% to 27.4%.
Oh, that's
Show it off, show it off. Let's all see it.
Oh, okay. We're gonna keep going.
It's like a frame.
What did you guys have for your interval?
Oh, mine was 0%.
0 to 31. Okay.
Star kicker list.
Kelly?
0.11 to 0.35.
Okay, so 11% to 35%.
Oh, yeah.
Yeah. No, I just want to make sure we're all okay with.
Are you drawing it based on the numbers?
Yes.
Sort of.
That line in the middle matters. So probably don't have one, right? Yeah. Stacey?
60% to 41%.
16 to 41. Okay.
Oh, I don't know.
2.56%.
I'll have it as soon as I figure out what S is.
I don't know what. What do you mean S? We need Z crit, P hat, and N.
Wait.
It's a proportions.
X.
Oh no, it's B hat.
Yep. Right, Bryce? Negative 11%. Okay. We're gonna just go 0 to 31. We'll pretend 0 somewhere in here, okay? Okay.
13.5% to 37.
somewhere like that.
21% to 47%.
Oh, 21 to 47, sorry. We'll come back. Would you?
18.5% to 44.8%.
Okay, something like that. Jackie?
37.8%. Sorry, 13.5% to 37.8%.
Somewhere in there. I'm clearly not being super precise with the
11.3 to 30.5.
Okay.
4.5.
Aiden, what about you?
4.5.
Karen?
8.9 to 31.
12.3, is that? 4.3, oh, okay.
6.7.
Okay. Somewhere like that. Okay. So each of these is your little interval up here. This line in the middle, that black line, that is the truth. That is the actual true proportion of red M&Ms. It is 13%. Okay? So did every interval capture the truth? No. Was our sample size really big enough for this to work perfectly?
Not really.
No, not really. But did we do okay? Were a lot of them captured the truth or pretty close to capturing the truth? Okay, that's what a confidence interval does. Okay. Questions over the M&M's part? Like I Googled M&M's and there. Like the company tells you which percentage should be
Hold on.
which
I was
color.
gonna say that like wouldn't just be 1/5.
It's not. There's difference. They have different proportion between the colors.
Wait a
Brown's
minute.
definitely the most common.
I don't know. I don't know.
Brown is the most common, isn't it?
I don't know. I don't remember.
Hey, wait a minute. I'm sorry. So
There's a lot
So
of
conditions state that both P and N minus P
Why?
and 1 minus P times N has to be greater than 10 in order for normality to be assumed, right?
Right. We did not meet that condition in most of these cases, right?
Yeah, because
That's what I was saying, that our sample size was really not big enough to make
Yeah,
this
so
work,
this-
but I couldn't give everyone like 200 M&Ms, so.
yeah, that would. All right, I'm
Fair.
satisfied.
Well, yeah, I mean, like, bring your own M&Ms today, guys. All right. Yes. Randomly. All right, let's look at this solving for sample size. I know I'm jumping around just a little bit. Every once in a while, guys, you're going to get a question that says, what would the sample size need to be to have this specific margin of error? This is kind of the only time in statistics where you're going to have to do any algebra. Okay, so you are given whatever margin of error you're looking for. Based on the confidence level, you can figure out the critical Z value. This 0.5 and 0.5, when we don't know the proportion, you assume 0.5 and 0.5. It's actually going to give you the highest value in here, so that's what we always go with to be safe. And then dividing by n is what you're actually solving for. Okay? So anytime you're solving it, solving for sample size based on margin of error, this is the formula you have to look at. So let's try to do that in part B of this. All right, so we wanted to estimate the proportion with 95% confidence within 2%, so plus or minus 2%. That means my margin of error equals that 2%, okay? I'm looking for the sample size, so looking for n. We know our p-hat from up above, right? 0.7045. Yes. Okay. All right, so the formula, just jot it down here, margin of error has to be, we always set it greater than or equal to our z crit, which was 95%, times our standard error. So in this case, we're doing 0.02, and then our critical z value was 1.96 for 95%. Okay, square root 0.7045 times 1 minus 0.7045 all over n. All right, stop there for a second. I want to make sure everybody's okay with where all of those values came from. David, you look like
What's this?
just your standard error. That's just the square root portion of it.
So in terms of find n.
Yes. But again, I want to make sure we're okay with the formula. Yes? What, stretching over here? Yes, okay. Fun. Corner. All right. So to go about solving this, how do I do this? Divide by your 1.96. So we've got 0.02. And guys, if you want to turn it to an equal sign to work on solving it, that's completely fine, okay? And then I've got the square root of all of this. How do I get rid of a square root? Yeah, so you're going to have to square both sides of this equation. So I've got 0.02 over 1.96 squared. And then 0.7045 times 1 minus 0.7045 over n. What do you have to do algebraically to get n out of there? You multiply by n, and then what are you going to do? Yeah, so are you guys okay with n is going to equal this divided by this thing that's squared? Sounds good. Again, it's like the only algebra that just works. I know some of you want to key things in along the way. That is fine, but you cannot round your answer. Don't round an answer to find another rounded answer. Okay, never use a rounded thing to find a rounded thing. This is divided by. You can certainly store these values. Anybody have an answer for me? Okay, I'm hearing. Let me grab my calculator. There's a lot of different answers. What? I'm sorry.
Right.
No, looking at your answer, I'm trying to say that probably would make sense. This sample is 1,100, so it should be smaller than that. I know, but I'm just saying, you're trying to calculate the real number, like of the 95% that should be smaller than that for sample size.
But we want a specific margin of error. Is it what? I'm sorry. I'm getting 1,999 point something. Do you think we should have part of something if we're talking sample size? No. Do you think, even though it's 1,999.4, do you think we should round down? No, always round up. That's why that initial, we want it to be like at least this. So I would take 2,000. That's your sample size, okay?
But, the decimal.
Yes. So guys, if you put the decimal in for sample size, that's not okay. You can't sample, 10 people and someone else's arm. You can't, okay? You can't do parts of things when you're taking a sample size. Okay? So always round up when we're talking sample size. All right, questions on that one? Okay. Let's start on this last one here. All right, so we have the Platinum Gas Saver. It's supposed to increase gas mileage by 30%. And then you're given this data for 15 randomly selected vehicles. And this is how the gas mileage changed. So if it's negative, what do you think that means? What happened to the gas mileage? Yeah, it actually got worse, okay? The positive values, the gas mileage increased. So I want you to construct a 90% confidence interval for average percent change in gas mileage. So is this a means or proportion problem? Means, okay? Do we know X bar or S? Do we have data points so that we could find those? Yes. What do I have to do with those values? Yeah, stat, edit, 1 bar stat, okay? And this is just a sample, so we don't have sigma. We don't know the standard deviation of the population. We don't know mean. We don't know sigma. We can find X bar. We can find S. And we know our sample size is 15. So I'll give you a little time here. Start plugging that in. What are you getting for X bar? 29.43. What about S? 16.24. Okay. What should we always do next?
Condition.
Conditions, okay. All right, is it random? Yes, why? Stated. Okay. Checking for normality. All right, N is definitely not big enough. Big enough, it's only 15. What else could you look at? Normal probability plot. You've got all these data values, you can plug them in. Check your normal probability plot. If you don't remember where to find that on your calculator, raise your hand and I will come help you, okay? You're going to check the normal probability plot. How does it look, guys? I'm not looking for a perfect line. Is it approximately linear? Yes, okay. Is approximately linear. Okay. So we could then continue with the procedure. We're gonna stop here today. Just we have, a minute left. Would this be a Z or a T? T. Why is it a T? Yeah, we don't know sigma. Sigma's unknown. Okay. All right. So we'll finish this last one next time, and we'll do a bunch of practice. Your test. 7th period is my planning period, so I will have them done by the end of today. You are welcome to stop back at the end to see your scores if you want to see that. You won't be able to look at the test for a little bit though. Probably not today. Still drowning. So I'll get them graded, but they won't be in SIS yet.